voltage drop testing, you'll hear me mention throughout all of the lectures if I haven't done it already. But I want to go into detail about it because it's one of the only tests out there, the best, I mean, I'm pretty sure there's more of them out there, that will help you find the dreaded unwanted resistance. Unwanted resistance is caused by corroded connectors, loose connections, frayed wires, something in the middle, an insulator, something that is partially blocking the flow of current, and anything that has resistance, voltage has to drop over it. That's how all of our loads work. The light bulb has resistance, so the voltage drops across it, and it works. So when you're working with a circuit, or even testing a circuit, because we have multiple ground points throughout the car, and one ground point shares multiple circuits. For example, they're not going to put 20 different grounds all in a row when they can just attach them by a pigtail and use the same bolt. So when you have a circuit that is running, when you have multiple circuits that are running incorrectly, not working right, running slow, dim lights, you can, I don't want to say assume, you can deduce, which is you can kind of think about it. They may all be sharing the same ground, and that same ground may have unwanted resistance. So how do we find it? We do voltage drops. So if our circuit here has 12 volts fully charged battery, if we were to put our positive lead here, negative lead here on a wire, which is a conductor, should there be any resistance to that other than what's calculated in it? No. So what we would see is pretty much near 0 volts, which isn't acceptable. I think from the front of the car to the back of the car, we can have 0.2 volts dropping across everything. So if we go to here, which is the load, if we do a voltage drop across this load, no matter what that resistor is, because there's only one in the circuit, it should be 12 volts dropping across there. And if we conduct the same test across the ground wire, there should be close to 0 volts dropping there. Because why? Yes, voltage has to drop over resistance, and even though a wire is a conductor, there's a certain amount of resistance to it. That's just the nature of the beast. Now, where this comes into handy is if we have unwanted resistance in a circuit. So, I don't have my rag with me. My eraser. If this was a 3 ohm resistor, 3 goes into 3. If we want to figure out the voltage drop using Ohm's law, we'd have to know the amperage of the circuit. So 3 goes into 12. It's a 4 amp circuit. Figure out the voltage. 3 times 4 should be a 12 volt drop. That's what we would expect to see. Now, what happens in a car is that we get a pesky little thing called unwanted resistance. And it can happen anywhere. Well, resistance is resistance. So now this little resistor becomes, this unwanted resistance becomes a 1 ohm resistor with resistance. So does that change the whole dynamic of the circuit? Yes, it does. Because in a circuit, we have to add up all the total resistance. So how would you find that? Well, Miss D, it's not calculated into it. We wouldn't know it's there. Oh, you're very right. Okay. So you would have to do voltage drop testing, okay? So if we dropped or did a voltage drop test here, this goes into 4, make that 4, I gotta figure out my current, where this becomes 3, okay? So if we put our lead here and here to see our voltage drop, okay, 1 goes into 3, this would be 3. We're dropping 3 volts just on that ground. And here, 3 goes into 3, 9. So now you can see how the effect of an unwanted resistance in a circuit is going to affect the whole thing. That light bulb would be dim. So let's say you have a parallel circuit where one's dim and one's not, and I've seen them. You see them on headlights all the time when they're driving down the road at night. One headlight's really dim and one's really bright. One of those headlights has unwanted resistance on it. And that changes the whole dynamic of that circuit.